The triangulate modifier is designed to take all of the faces on your model and convert them into triangles. Whether they be 4-sided quads, 5 or 6-sided n-gons, they will all be converted to triangles with the triangulate modifier. To access this modifier, go to the Modifiers tab in the Properties panel. From here, select the Add Modifier button, go to Generate, and then come down to where it says Triangulate. Left click to add the Triangulate modifier to your object. First of all, let's take a look at how the Triangulate modifier affects our models when it is applied. I'm going to add a Triangulate modifier to 3 different objects. So first of all, we've added it to our cube object, but nothing appears to have happened, at least visually in the 3D viewport. We also have the cylinder object. Again, we're going to add Triangulate. And again, that doesn't seem to have made too much of an impact visually. But now let's take a look at Suzanne, where we're going to add our Triangulate modifier, and pay close attention to Suzanne because it has a lot of faces that are sort of bent in a curved way. So I'm going to go Add, Triangulate, left click, and you should see on your model, if you're using Suzanne as part of this example, that the shading of the object has changed, and we're now able to pick up some of these triangles that have been generated using the modifier. Now let's apply the modifier on each of these objects. To do that, just open up the menu, then select Apply. I'm going to do this for all 3 objects. And now, for each one, we're going to go into edit mode. So we're going to go edit mode first of all for the cube, and actually we can select all 3 if we want, and then go into edit mode for all of these objects. When we do that, you will see that we have generated triangles on all 3 of our models. So wherever there was a 4-sided face or even a 5-sided face known as an n-gon, the Triangulate modifier created new geometry in the form of triangles that broke up the faces that had more than 3 sides. On the cylinder, you can see this is especially the case with the geometry that has been created here at the top and at the bottom. So it's done its best to try and create 3-sided faces, no matter the angle or shape, so that we can use this geometry for a variety of different tasks. Now you might wonder, what is the purpose of turning all of your geometry into triangles? Well, one reason why you would want to do this is because in game engines that use 3D assets, they work with objects in terms of their triangular count. So they like to work with 3-sided faces more so than 4-sided faces, which are otherwise known as quads or n-gons. So if you're prepping an object to be exported to a game engine, it might be an idea to use the Triangulate modifier first to allow the geometry to take on a form and a style of behavior that would be similar to that in the game engine that you are using. The Triangulate modifier is most similar to the Triangulate tool. Here I have a torus object that exclusively uses 4-sided faces. I'm going to go into edit mode for this object, and then I'm going to go to the face menu, and I'm going to locate the ability to triangulate my faces. You can also use the hotkey Ctrl and T. I'm going to left click, and it will convert every single one of our faces into triangles. This significantly increases the amount of geometry, but the geometry is as simple as it can be. We can open up the operator panel and define the methods for quad faces and n-gon faces if we wish, But keep in mind that this is the tool variant of the triangulate modifier. So once you use the tool, you cannot manipulate it once you move on to another tool, such as the ability to manipulate the positioning of your geometry. We can combine the triangulate modifier with other modifiers in the stack. For example, I can begin by adding a triangulate modifier to the cube. I can then add a second modifier, such as a wireframe. What happens here is we create the new geometry with the triangulate modifier, and then we convert all of that geometry to a wireframe. But what happens if I was to swap the positionings of these two modifiers? If we put the wireframe on top, then the triangulate modifier seems to disappear, but what actually happens is it will just attempt to find any of the newly generated faces created by the wireframe, and if those faces have 4 or more sides, it's going to convert those faces into triangles. Another example may be with the subdivision surface modifier. So I can add the subdivision surface modifier, and here you can actually see that we've created a very interesting looking sphere. If I was to hide the effect of the triangulate modifier, you can see this is the standard effect for the subdivision surface, and we can increase the number of subdivisions here. But as we show the triangulate modifier, it has a profound impact on the shape of the model because of the additional geometry that triangulate is creating. Again, we can change the final result by changing the order of the modifier stack. Here it looks a lot more like you would expect from using subdivision surface, but if you pay close attention, you may see some faces that have clearly been divided into triangles, and actually this is going to be the case for all of the faces on our model. It's just that it's going to be more visible at certain areas. For this example, we have something that has 4-sided and 5-sided faces. So it's very clear in this example the type of geometry that we're working with. And this should allow us to better see how the triangulate modifier is operating on our models. So I'm going to add the triangulate modifier from the menu, and keep in mind that we are having the wireframe option ticked for our viewport overlay so we can see the geometry in object mode. Let's add triangulate, and this is going to create triangles everywhere where it feels able to, which in this case is the entire model. Now, starting with the quads, which go all the way around the model, we have a single line that cuts a 4-sided face into 2 separate triangles, and that's the case all the way around the model. It's a little bit more complex when it comes to a 5-sided face. We have 2 lines that have been generated here. We have a line that comes across that allows us to create a triangle at the very top, and then we have a second line that comes across diagonally to create the final 2 triangles from what was eventually created as a quad. So think of it this way: when it comes to the n-gon at the top, we had 5 edges to create a single face. The triangulate modifier then creates the first cut, which is probably here, which creates 1 triangle and 1 4-sided face, and then with the 4-sided face it creates a second edge to divide that quad into 2 smaller triangles. Before we look at the quad and n-gon methods, I just want to highlight the minimum vertices option here. So as we may have previously mentioned, this is the minimum number of vertices that a polygon must have for it to be affected by the triangulate modifier. Now we can't go below 4 vertices here because 4 vertices will make up a quad, and the next step below is a triangle anyway. So the triangulate modifier cannot work on triangles that already exist, which is why we can't reduce this value below 4. However, we can increase this value. At the moment, it's set to 4. Now, if we set this to 5, then theoretically it should no longer work on any of the 4-sided faces or quads on our model. If I increase this value to 5, we see exactly that. So the triangles here, or the additional edges, disappear around the model. But where we had our n-gon, which is our 5-sided face, we still have the triangulate modifier working to create those triangles out of that 5-sided face. If I set this to 6, then even that geometry will disappear, because we set the minimum number of vertices to 6, and this n-gon only has 5 sides, it's not going to be affected by the triangulate modifier. So this can make things quite useful if you want to keep your quad-based geometry, but convert n-gons to triangles. Then what you would do is you would simply increase the number of vertices, or minimum number of vertices, from 4 to 5. This way you would be able to use the triangulate modifier to fix the n-gons so that they have 3 sides instead of 5, 6 or 7, but you would also maintain the quads, and the quads may be important to your object's topology. Let's take a look now at the triangulate modifier's quad method. So this is effectively a menu of different ways in which the triangulate modifier is going to break up your quad-based meshes into triangles. If you open up this menu, we have 5 options: beauty, fixed, fixed alternate, shortest diagonal, and longest diagonal. So what do each of these mean? The first option is beauty, and this by definition is just trying to create the best looking triangles and the best looking geometry that Blender can create with the triangulate modifier. So this takes the location and position of each individual quad, and it will attempt to triangulate that quad in a manner in which helps the topology rather than hinders it. The second option is fixed. When we use the fixed quad method, we will take each individual face, and for each face, each of these vertices is going to be assigned a number. So let's take this face right here, for example. This one can be vertex 1, vertex 2, vertex 3, vertex 4. And what happens with the quad method when it's set to fixed is it will go from vertex 1 to vertex 3. If we were to switch this to fixed alternate, it would go from vertex 2 to vertex 4. And if we zoom out, this is why when it comes to the fixed or fixed alternate options, for most of the model, we can see all of the triangles and the edges created, they all seem to follow the same direction. And this direction can be switched depending on the quad method. So fixed goes in one direction, fixed alternate will go in the other. The final 2 methods are based on the length in between your vertices. So here I've got a custom plane where we have 3 vertices in their original position, but we've branched this 4th vertex out. Now I'm going to add my triangulate modifier to this example, and it automatically goes to the shortest diagonal. So the shortest diagonal here for this quad is from this vertex to this vertex. The longest diagonal is going to be from this vertex to this vertex. Theoretically speaking, if we change from shortest diagonal to longest diagonal, it's going to change so that the edge created is done so at the longest distance between any 2 vertices on the face. Now, as an added tip, this is the recommended option if you are using triangulate on a model that is going to be used for cloth simulations. It's just proven that this will give the best results when creating cloth simulations in Blender to use the longest diagonal quad method ahead of any of the other options. When it comes to the n-gon method, we're just going to use the cylinder as a simple example, because with the cylinder, we have one large n-gon on the top and bottom of the object. So let's just add our triangulate modifier. And the n-gon method is used to determine how n-gons, which are of course faces that have more than 4 sides, are going to be converted into triangles. Now if we press 7 on our number pad, we can go into top orthographic view. And here you can get an idea as to how the geometry is being formed. There are only 2 methods for n-gon, beauty and clip. And the key difference between the two is that beauty is going to try to more evenly distribute those triangles across the n-gon to create a better visual result, whilst the clip method works in a slightly different manner. It uses a more radial form of calculation, and this effectively is used to save on performance. So in short, beauty is for the best visual result. Clip is typically for added performance within the 3D viewports. Back with Suzanne, we're going to once again add the triangulate modifier, but this time let's take a little look at this keep normals option. Now this is going to be used when you create customized normals for your individual faces and you want to maintain those changes. By default, we obviously haven't done anything to the individual normals of our model, and this is what's going to affect the shading of the final result. So if I was to temporarily turn on face orientation, you would be able to see that all of these faces are pointing in a certain direction based on their color. So red represents the inside of a face, which you should not see, and blue represents the outside of the face, which is the normal direction, and that's what should be viewed. But we can edit these normals and how they are operating on each individual face. To do that, I'm actually going to add a different modifier under the normals section. I'm going to use the weighted normal modifier, and this instantly makes a change to how the shading works across our model. It almost in a way adds a form of smooth shading in this instance. If I click and drag the weight option, I can change how the weighting of the normals affects the shading of the model. So here I'm going to add a triangulate modifier after the weighted normal modifier. And you can see here that the shading is mostly intact, but if we click on the keep normals option, you can see that the effect is more precise to what we had before using the weighted normal modifier by itself. This might be a little bit tricky to see while we've got the wireframe active, so I'm going to turn that off. And if we just turn off triangulate and turn it back on again, you can see there isn't that much difference in the shading. There's a little bit of difference in terms of the geometry, because of course we're converting the geometry into triangles, but the shading is mostly intact. If I turn off the keep normals option, you can actually see there is a substantial difference here in terms of the appearance for our model. You can actually see all of the triangles because they all have different shades compared to the adjacent triangle that was generated with the modifier. Here, for example, we've got 2 tries where there was once a single quad. But now both these triangles have their own normal values. If you don't want that, that's when you click on the keep normals option, where both of those faces that were generated would have the same normal direction, and therefore you wouldn't get the visual artifacting of the triangles appearing when you don't want them to. That wraps up how to use the triangulate modifier in Blender. I hope you found the tutorial useful, and if you want to learn more, don't forget to like, subscribe, and click the notifications bell icon for updates and future Blender tutorials here on YouTube. For now, I'll see you next time.